The Anthropocene ocean. Many researchers now use the term Anthropocene to describe the present geological epoch characterized by large-scale human influence on Earth's environmental systems. Evidence for this influence appears across multiple domains. Atmospheric carbon dioxide concentrations now exceed pre-industrial levels by a substantial margin. Deforestation and land use change have altered terrestrial ecosystems worldwide. Species extinction rates have accelerated beyond historical background levels. The ocean records these transformations particularly clearly. Sediment cores collected from deep ocean basins now contain microscopic plastic particles alongside natural minerals. These particles form part of a geological record that may persist for thousands of years, marking the era in which human industry became a dominant environmental force. In this sense, the ocean functions not only as an environmental regulator, but also as a historical archive. In this sense, the ocean functions not only as an environmental regulator, but also as a historical archive. It stores physical evidence of humanity's industrial expansion. Satellite systems began monitoring global sea surface temperatures, ocean currents, and biological productivity. Autonomous profiling floats deployed through programs such as Argo started collecting continuous data on temperature and salinity across the world's oceans. Meanwhile, deep-sea submersibles and remotely operated vehicles allowed scientists to explore ecosystems thousands of meters below the surface. These technologies revealed environments that earlier generations of researchers could scarcely imagine. Hydrothermal vent systems support biological communities, powered by chemical reactions rather than sunlight. Cold seeps release methane and other hydrocarbons from the seafloor, sustaining specialized ecosystems adapted to extreme chemical conditions. Deep trenches host organisms capable of surviving enormous pressure and permanent darkness. The deeper scientists looked, the more biological diversity they discovered. A strange overlap when viewed together. These developments reveal an interesting overlap in the historical timeline during the same decades when environmental pressures on the ocean intensified through plastic pollution, industrial waste, and climate-related changes. Scientists were also discovering ecosystems far more complex than previously imagined. The ocean was becoming both more threatened and more understood at the same time. This dual pattern complicates simple narratives about humanity's relationship with the sea. Technological systems have allowed researchers to observe marine environments in unprecedented detail. Yet the same industrial and technological processes enabling those observations are also contributing to environmental change within those environments. The relationship between human civilization and the ocean is therefore not simply one of exploration or exploitation. It is an evolving interaction between two complex systems. The next layer of the timeline up to this point, the developments described in this essay belong primarily to environmental science and oceanography. Yet in recent decades, another category of observation has occasionally appeared in discussions about the ocean. Some of these observations originate from naval sonar operators. Others appear in declassified reports or public documentation. Many involve unidentified objects or unusual signals detected within marine environments. The interpretation of such observations remains uncertain, but their existence highlights another aspect of the ocean that remains difficult to ignore. Despite centuries of exploration, the largest environment on Earth is still only partially observed. The next section examines what that means for detection, interpretation, and scientific uncertainty. Did you enjoy this essay? Let me know below. Like and follow for more.